Hey guys, it's Sam here again. And let's continue on from what we did last time. We've been looking at something called a mole map. And this mole map, I'll pull this down a bit more, it's a little too bright for me. The mole map is just a way of showing you how to go from one unit to another using in science terms. Different amounts. It's like going from ounces to pints. Those are amounts in the English system. We understand a pint. We understand the gallon. We understand inches. We understand feet. It's the exact same thing. Converting from inches to feet or feet to inches is the same thing as what we're doing here. It's just terms you're not familiar with. That's why we give you the mole map. We give you the mole map to work with so it helps you. Just like when you're elementary school, they told you 12 inches equals 1 foot. They told you 1 mile equals 5,280 feet. That's an equivalent statement. The equivalent statements are what you're seeing right here between the boxes. That's what equals each other. Okay, so let's talk about this. Now, we've done the mass to particle and the mole to particle and the mole to mass. We've talked about those two. There's one more little connection we need to make sure we're looking at. It's a mole to volume relationship. Mass is how much stuff we have. It is a mass, it's grams. Particles are the individual pieces of it. It's an atom, it's an ion, it's a formula unit if it's an ionic compound, it's a molecule if it's a covalent compound. So we've got those two parts. Now we're going to look at volume. Volume is how much space something takes up. It's based on space, not necessarily particles, but space. Okay, so that's what we're looking at with volume, is how much space something takes up. Now when we talk about volume, you got to talk about something called STP, and let me put me over here. STP, standard temperature and pressure. That's what the S stands for, standard, T is temperature, and P is pressure. There's a and standard means what we look at overall. So there's a standard temperature. Standard temperature is 0 degrees Celsius. And the pressure is 1 atmosphere. These are scientific terms. Now you're like 0 degrees Celsius, that's 32 degrees Fahrenheit. Okay, so just know it's 0 degrees Celsius. We use Celsius. And 1 atmosphere is a pressure. It's how much force is being put on something. But STP is just a term we use here. We won't get into gas laws. You'll do that if you go on to AP Chem, or you may see it in AP Bio. But STP is just a standard we use. It really means nothing else here for us right now. And you probably won't see it again. You just have to know what STP stands for. Now, at STP, at standard temperature and pressure, 1 mole, 6.02 times 10 to the 23rd particles, will occupy a space of 22.4 liters, no matter what the gas is. And it has to be a gas. So any gas, 1 mole of any gas, 6.02 times 10 to the 23rd particles, will take a space of about 22.4 liters. It's called molar volume. Molar volume. It's the mole, the volume of a mole. That's why it's called molar volume. 1 mole of any gas takes up that much space. Okay? That's what it is. And we had this box in the classroom. Unfortunately, I don't have it here with me, but that's 22.4 liters. And if I had any gas, if I had 1 mole of any gas, it would take up that much space. Okay, so let me show you this. So you have these 3 different gases here, and I'm trying to find there it is. I have a little drawing tool. Let me move this down here. There we go. So I have 3 different gases. I have helium in this tank here. I have xenon in this gas here, noble gas. These are both noble gases. And I have methane right here. So I have an element, and this is a molecule, a bunch of molecules of methane. So 1 mole, there's 1 mole right here. 1 mole of helium has a volume. We measure volume in liters. Volume is measured in liters. That's what we use, the capital L, okay? So 1 mole of helium will occupy 22.4 liters of space, no matter what. 1 mole of xenon, again, will equal 22.4 liters, no matter what. And 1 mole of methane at STP. This is at standard temperature and pressure. Now, if you change the pressure or temperature, things are going to change, but we're not going to do that in this discussion, okay? Everything will be at STP. Will always equal 22.4 liters, no matter what. So let's look at this something else here. Let me get rid of these. And go back to the mouse so I can move it. So what does this really mean? Got a little distorted here, sorry. So what it means is this. So let me get a different color. There we go. So if I have 1 mole of helium, 1 mole, now remember 1 mole means 6.02 times 10 to the 23rd atoms. It's atoms because it's an element. Helium is an element. So if I have that many atoms of helium, that's 1 mole. Now, 1 mole of helium equals 4 grams. How do I know that? I look at my handy dandy periodic table. And if you look on the periodic table, if I have right side up, here's helium, 4 grams. Okay? And it takes up 22.4 liters of space. Now here's a mole of xenon. 1 mole of xenon also has 6.02 times 10 to the 23rd atoms of xenon, because xenon is an element, therefore it's atoms. And xenon has a mass right here on my periodic table, if you can see it, of 131.23 grams. So if I have 131.23 grams, which is 6.02 times 10 to the 23rd atoms, it will take up 22.4 liters of space, no matter what. Now, let's look at molecules. If I have a mole of methane, methane is in a covalent compound. So it's a covalent compound, therefore the unit of particles is a molecule. 1 mole of methane is going to have 6.02 times 10 to the 23rd molecules of methane. That's how many, if I had to count them out, I'd have 6.02 times 10 to the 23rd molecules of CH4. Well, if I do my molar mass, carbon is 12.01. Each hydrogen is 1. So 12 times 4 is 16. So 1 mole of methane equals 16.05 grams. Now, it's a little bit different than our periodic table, but that's okay. And 1 mole of methane also equals 22.4 liters. So it doesn't matter. The mass doesn't matter. It's mole. 1 mole of something equals this much space. Okay? So let me erase this so we can move forward. So how do we work with this? Well, we do this. So converting from moles to volume, the conversion factor we're going to use is 1 mole equals 22.4 liters. That's an equivalent statement. 1 mole of anything equals 22.4 liters, no matter what it is. So here's my mole, and there's volume. Okay? So when I go between moles and volume, in volumes to moles, I'm going to use this conversion factor right here. Okay? So now I'm going to switch over here for a second so I can show this to you on my whiteboard over here. Here's lovely today, I know. Okay, so there you go. Oh goodness, let me get rid of this light here. There we go. So let me see if I can focus in on this. Okay, hopefully you can see that. Let's get it in focus. Oh my. Maybe, maybe not. It's struggling. Let me try it with something else here. Let me actually use a piece of paper. Let's see if this works. I had it bigger and I didn't use it, so let's see if this works instead. Well, it's kind of hard to see, but I think you can see it enough. Hopefully. Come on. Let's see if I can. Oh, let's turn it in. I want to do that. Okay, we'll just leave it like that for a few minutes. Maybe if I back it off a smidgen. Maybe if I turn the light back on. Maybe it needs a light. Huh, I think it needed a light. Well, look at there. Huh, we'll go figure. Okay, so now this shows you all of the moles, but we've already looked from mole to particles, and we've already looked from mole to mass. Now we're going to do mole to volume. We're going to go from here to here and from volume back to moles. And look what you have here. Going this direction, here's my equivalent statement. 22.4 liters over 1 mole. And going from mole to liters, you have this equivalent statement. I'm going to give you a minute and let you pause this. Well, I'm not going to give you a minute, but I want you to pause this and I want you to draw this. I want you to draw this. You don't have to draw the scale and stuff, but I want you to draw this mole map in your notes. You're going to need it, and you're not going to be able to go back and forth. So take a minute and draw this, okay? Pause me right now and draw this mole map. Okay, perfect. So now what we're going to do, we're going to go from moles to volume and volume to moles. Now let me see if since the light's on, let me see if this works better now. Okay, it's a little weird because it's a acetate. Let me see if I can set my little garbage can on it. No, it'll focus on my garbage can. Well, let's try it like this. Hopefully you wrote it down so you can see what I'm doing here. Now, let me zoom out a little bit. Oh, I don't want that. Okay, so if we have, oh goodness gracious. Give me 1 second, and I'm going to pause this and make a couple copies. Hold on. Okay, I'm back. I am so creative at times. It just makes me so happy. I found some like contact paper I put over top of it. So let me see if I can focus this. It was focused a minute ago. Excellent. There we go. Yay, now I can write on this thing. So we're going to go from volume to moles and moles to volume using these two equivalent statements right there. So let me get out a little bit. So let's say I've got 14.7 liters of neon gas. Let me move me again, get me out of the way. Okay, so I got 14.7 liters of neon gas. I want to know how many moles that will be. Well, I write down my given, 14.7 liters of neon. And now I'm going from liters to volume. I'm not from liters to moles, from liters to moles. So I'm going from liters to moles. So I'm going from here to here. So I'm going to use this arrow right here. See that little 1 mole over 22.4 liters? That's what I write right here. That's what goes there. 1 mole is on top, 1 mole is on top, 22.4 liters is at the bottom. Notice how the liters is on top, liters is on bottom. They cancel out. I take 14.7 divided by 22.4. Okay, so I take, clear it out, 14.7 divided by 22.4, and I get 0.66 moles. How's that? It's not that bad now, is it? I don't think so. Let's try another one. Oh, man, I wasn't as smart as I thought I was. Okay, I need to use the other one. Okay, there we go. Hey, it did work. Yay, Meg. Okay, so let's say I have, see if I can bring a little bit more. Okay, so let's say I have 1.02 moles of, Carbon dioxide, that's a gas. I want to know how many liters that will be. So now I'm going from moles to volume. Remember, this is liters up here, okay? So I'm going from moles to volume. So I say 1.02 moles of carbon dioxide. I want to multiply it by something to go from moles to liters. I'm going from moles to liters. So see this arrow right here? This is what I'm going to multiply it by right there. 22.4 liters. So 22.4 liters over 1 mole, over 1 mole. That way my moles cancel out. And I take 1.02 times 22.4, and I get 22.85. That 8 rounds that 4 up. So 22.85 liters. Isn't that exciting? It's so nice and so easy. You know, you just follow the mole map. If you follow the mole map, you cannot go wrong. If you ignore the mole map, you will be in trouble. So make sure you're just following this mole map. So I'm going to give you some of these guys a try, and then we're going to come back and we're going to do multi-step conversions. Okay? So take a minute and work on these. Volume to moles and moles to volume, and we'll be back. Okay, well, I hope you got those well. Let me see if I can autofocus this. There we go. Stay. Okay, so now what we're going to do, we're going to do what we call multi-step conversions. We're going to go from mass to particles, or from particles to volume. We're going to do several steps here, okay? Now, few things we have to remember. First, remember, volume is liters. That's where we're going to. Mass, I hope you know, is grams. And particles can be either a molecule, it can be an atom, it can be an ion, or it can be a formula unit. Okay, a formula unit. See if I can get the ULA in there. ULA. Okay, formula unit. Goodness gracious. There you go. Okay, so these are particles. So grams here, liters there, and if it's particles, it's one of those 4 things. Let's try some of these. So follow the mole map. That's the biggest thing you have to do. I'm going to zoom out a little bit so I have a little room to work. Okay, and let's autofocus. Let's see if I can get that thing to, close enough. Hopefully you've written this down. Add those other things to your mole map. You're going to need them. So please make sure you're looking at this. Okay, so now let's say I have 1.27 grams of, I'll just do sodium for now. Sodium. And I want to know how many atoms of sodium that will equal. So now I'm going from grams over to atoms. Okay, from grams to atoms. Now I can't go straight across. There's no way. You got to stay on what we call these roads. It's a map. So we got to stay on these roads that have been given to us. A road from here to here, a road from moles down to particles. There is no road through here, no road whatsoever. So you can't go straight from mass to particles. It just doesn't happen. So we're going to be going from mass to moles. I call it Moleville. You have to go through Moleville to get anywhere. So write down your given. My given is 1.27 grams of sodium. And I'm going to multiply it by something to get rid of those grams. Well, look here. So I'm starting with grams and I have to get the moles. I'm going this direction, aren't I? So I'm going to multiply it by this thing right here. I put 1 mole on top. Okay. By the way, a mole is abbreviated MOL. We just take the E off. So that's what a mole is. It's not a typo. When you start doing a lot of these, it really does shorten the time. But So 1 mole, and you see that word? It's molar mass. So it's 1 mole over the molar mass. Now where do you get the molar mass for sodium? Our handy dandy periodic table right here. Here's the molar mass of sodium, 23 grams. So we take 23 and put it down there. So that gram cancels that gram out. Grams are gone, and now we're at moles. We're in Moleville. But now we got to get down to atoms. So now we're going to go from moles to representative particles. So we're going to take this road right there, right? So I'm going to multiply by this thing here. What goes on top? What's on top there? 6.02 times 10 to the 23rd atoms over 1 mole. That way my moles cancel out. And I'm left with atoms, because that's what I'm looking for, right? I'm looking for atoms, so atoms it is. Now, when you do this, you're going to multiply the top by the top by the top. Let me get my pen. So I'm going to multiply 1.27 times 1 times 6.02 times 10 to the 23rd divided by 23. That's how you do it. So here's, I put it in my calculator. Here's how I do it, because I'm just weird that way, so don't mind me. So I'm going to take, let me focus in on this, 1.27 times 6.02 second E23. No 10, don't put a 10 in there. This is 6.02 times 10 to the 23rd. Hit equal. Then I divide it by 23, which is the molar mass of sodium. And I get 3.32 times 10 to the 22nd. Do not forget this little part here. Very important. Okay, so my answer is 3.32 times 10 to the 22nd. Okay, now if I were putting this into Schoology, I would write it like this, because you guys, I don't think you can do, you can write it 3.32 times 10 caret 22nd. That works. Okay, so 3.32 space times space 10 caret 22nd. That's how I'd write it in Schoology if you have to write these out. Okay, well let's do another one. These are fun. I love doing stoichiometry and mole map stuff. It is just, it's like a problem, solving a puzzle of some sort. It's just fun, fun, fun. So I got to work really hard to get these things out of here. Okay, so now let's try another one. Let's, sorry, my phone's buzzing if you can hear it. Okay, so let's say now I have 1.96 liters of water vapor. It's a gas. And I want to know how many grams that's going to be. Let's go to grams. So now I'm going from liters to grams. I got to go from volume to mole and mole to mass. Multi-step. So let's see what we can do here. So I write down 1.96 liters. That is my given. Correct? I'm going to use blue. It's a little better. You can see it, I think, a little better. So 1.96 liters. Okay? So I'm going to start here and look which arrow. I'm not going up, am I? So I'm going this direction. So I'm going to multiply by this equivalent statement right there. 1 mole over 22.4 liters. So I write just what's here. 1 mole over 22.4 liters. That way this liter on top and that liter on bottom cancel out. Perfect. Now I'm at mole. I'm in Moleville. Okay? Now I have to get the grams. So I have to head here. So I'm going from here down. So I'm going to use this arrow right here. So I'm going to multiply by the molar mass. Well, what's the molar mass of water? Well, hydrogen, we know, has a molar mass of 1. If it's H2O, Means I got 2 hydrogens. So 2 times 1 gives me 2. And I've got 1 oxygen with 16. So 1 times 16 equals 16. So my molar mass of water is 18 grams per mole. So I've got 18 grams on top, because molar mass goes on top, per 1 mole. That's how we get the grams per mole, okay? That way the mole on top and the mole on bottom cancel out. So I take 1.96 times 18. Multiply the top by the top. I hit equal. I divide by the bottom. Divide by 22.4. And I get 1.58 grams. 1.58 grams. Because that 7, we rounded up by that 5. 2 digits after my decimal. Okay? Does that make a little sense? And you can go back and forth on any of these. It doesn't matter. You can go from particles to grams. You can go to particles to volume. You can go from mass to particles, mass to volume. You just have to follow this mole map. Just follow the arrows and what it tells you to do. You have to look at this, okay? I'm going to give you something to try, and if there's any questions, we'll talk about it at our Zoom meeting. Okay, well, good luck, and you know how to reach me if you need some help. We'll give it, actually, let's try, well, let me try one with you. I'm going to give you a few minutes and let you try it. How about that? I feel kind of bad just leaving you on your own. Not that I would know if you got it or not, but let's just try one so you can say, yay, I got it. Whoop, I don't know what just happened. Silly me. Let me enter full screen. Oh my. Okay, so let's share this. So we did all those, and that's our, so if you could not see what I was giving you, take a minute and write this down. I forgot this was on here. So make sure you write this down. You need this mole map, okay? Make sure you have it down. Write this down. And remember, representative particles is molecules, atoms, ions, or formula units, okay? You have to remember that. And then we just did multi-step conversions. Yay. So let's try one more. I know. I just miss teaching with you guys. Let's try share screen. Let's do this one more time. I'm going to give you one to try on your own so you can feel so excited about it. Okay? So let's try 6.17 times 10 to the 25th formula units. I'm going to write FU just because I don't write formula units. Equals of chlorine gas. Okay, equals how many grams of chlorine gas? I'm going to give you a few minutes and let you try it. So pause me if you need more time. Okay? Pause me now. Okay, so what you do is write down your given 6.17 times 10 to the 25th formula units of chlorine. I'm going from formula units to mole first. So I'm using this arrow. So I'm going to multiply by that thing right there. So 1 mole over 6.02 times 10 to the 23rd. That's the same thing. This is the same thing as this, right? Just right like that. Yes? Yay! Now, I got to go from moles to mass. So I'm going this direction. The molar mass of chlorine. Now remember, chlorine is Cl2. Any of those diatomic molecules has to be, 2 chlorines, okay? So chlorine's 35.45 grams, so it's 70.90 grams over 1 mole. Okay, does that make sense? That way the formula units cancel out and the moles cancel out and we're left with grams. So you multiply the top by the top. So 6.17, second E25 times 70.90 divided by 6.02. Oh my goodness, Meg, what are you doing? Oh, hold on a second. I don't know how to get out of this. So I gotta start all over. Oh, there we go. No. So 4.37. I'm just gonna start from the beginning. 6.17 second E25 times 70.90 divided by 6.02 second E23. And I have 7,266.66 grams. That's a lot of grams. So 7,266.66. Oh, a lot of sixes there. Okay. Or if you want, you can always write it 7.27 times 10 to the third. I would kind of prefer this. It'd be easier to put that into Schoology. So kind of, if you can, keep them out of scientific notation if you can. So that makes sense. I hope so. Just remember, whenever you do mass, your diatomics are by 2. That's the only time it happens. Okay? Follow your mole map, and I think you'll be fine. Okay, well, I will see you later, and have a good week. I'll see you tomorrow. Bye.